Hi everyone, in today's lesson we're going to talk about a function that is continuous. So a function is continuous at any given point if and only if the limit from the left is equal to the limit from the right, which is equal to the value of the function at a specific x value. So here's the formula for continuity, where the limit from the left must equal the limit from the right, which must equal the value of the function at x equals c. So here's a visual representation. So let's just say I want to take the limit at x equals c, which would be right here. This is a closed circle. So we see that the limit from the left equals f of c, or some y value, and the limit from the right equals that same y value, and the value of that function f of c is still the same y value. So that proves that it's continuous. Another way to determine visually if a function is continuous or not is to just do the pencil test. So you would start with your pencil here and you would drag, and follow the function along. And if you don't have to pick up your pencil to follow or jump over anything, then the function is continuous, continuously moving back and forth without picking up your pencil. So now let's talk about types of discontinuities. So there are a couple of different types. The first type is called a removable discontinuity, or a hole. So at x equals a, there's a hole in the graph, therefore this function is discontinuous. Well, let's do the pencil test. So we're going to start with our pencil here, trace. We have to jump over the hole, pick up our pencil to continue tracing. Therefore, it's discontinuous because it's not one fluid motion. All right, here's another example of a hole. Same thing, trace, jump over the hole, continue my tracing. So since I had to jump over the hole, we now know it's discontinuous. Then we have infinite discontinuities, which are vertical asymptotes. So here are 3 examples of vertical asymptotes. So let's do the tracing test. So we're tracing here, we go up. Now we have to jump over the discontinuity to get to the other branch. Trace. Same thing here. We're tracing this branch, jump over the discontinuity, and we're coming back down, okay? So we have holes, we have vertical asymptotes. Then we have jump discontinuity, where we jump from one branch to the other, or a piecewise function. So we've got tracing. We have a hole, we jump up, and we come back up to the next discontinuity. An endpoint discontinuity is just the end of a function that ends, that doesn't have an arrow. So we are not continuously moving because of that endpoint. And then a mixed discontinuity is just one where you may have a hole and, say, a vertical asymptote. Either way, this one is still discontinuous. So a question that you might get asked is a function like this continuous at x equals 3? So this, we know, is a piecewise function. So you may need to write this down. I believe there's space on the back of your paper if you want to just continue. So pause the video, write this problem down, then we'll go over it and we'll be finished. All right, so in order to check if a function is continuous, we have to use the formula. So we need to decide, is the limit from the left equal to the limit from the right? And is that equal to f of c, or in this case, x equals 3? So we need to test to see if all the 3 things are equal. If they are, then the function's continuous. If they're not, then they're not equal. So remember how we did limits of piecewise functions. We decided that if I have x is greater than 3, moving to the right, this is the right side of the graph. And if I have x is less than 3, then this is the left side of the graph. So if I want to find the limit from the left, I am just going to plug x equals 3 into the left side. So 15 minus 2x, and let's plug in 3. So 15 minus 2 times 3. So 15 minus 6 is in fact 9. So now if I want to find the limit from the right side of the graph, I'm going to plug into where it says x is greater than or equal to 3. So in this, 18 minus x squared. So now I'm going to plug in 3. So 18 minus 3 squared. 3 squared is 9. So 18 minus 9 is 9. So it looks like the first 2 are equal. And then the last thing I need to do to prove that it's continuous is find the value of f of 3. Well, to find this value of f of 3, we always have to use the function that has the line under it. So this one, where x is greater than or equal to 3. So that would be the branch where we would be equal to 3. So we're actually going to just follow that same function, 18 minus x squared. And we just did that, 18 minus 3 squared, 18 minus 9, that is in fact 9. So since all three of these things are equal, the function is continuous. So we can write a sentence that says, yes, f of x is continuous at x equals 3 because the limit from the left, so we can actually write it, instead of writing it out, we can actually write it out in symbols. So because the limit as x approaches 3 of f of x from the left minus is equal to the limit as x approaches 3 from the right of f of x, which is equal, I should have moved this over, sorry. So I'll put it over here, equals f of 3. So since all three things are equal, we know the function is continuous. All right, that's it for today. If you have any questions, please jot them down and ask us in class tomorrow. All right, have a good night.